Let's continue with ISOMETRIC-2, ISO 2. And we will take our orthographic views and convert them into the isometric view. Looking at the front view, I can see that I have what appears to be a rectangular prism with a round bottomed slot cut through it from front to rear. So I'll start off and I'll just lightly construct the rectangular prism. 1, 2, 3, 4, 5, 6, 7. And it looks like the orthographic grid matches the isometric grid. Now that the box, if you will, is constructed, I'll locate where the slot appears on the front face. 1, 2, 3, 1, 2, 3. This becomes the center mark for the elliptical shape. And since I only have half a circle, I only need half a parallelogram. 1, 2 for the radius. And the parallelogram will be oriented toward the front face. Now, this will be my flat curve, and this will be my rounded curve. Now that I have my two arcs in, I'll extend those construction lines to the top surface to match those lines, and then I'll move my center point from the front to the rear. 1, 2, 3, 4. Now, I construct my parallelogram again. Here is my flat arc and my rounded end arc. The top surface is only 1 wide on this side, but it is 2 wide here, and so that becomes the top surface. This part of the rear elliptical shape will not be seen. Then I will take my pencil, my darker pencil, and I'll go ahead and include my visible lines. I'm straight to here. There's my curve. Straight. It's my curve. Curve comes around. Straight to the top. And with the visible lines included, that's what problem 1 looks like. Problem 2 is very similar in that we have a round-ended slot that comes and projects through on the top surface, and then I have 2 inclined surfaces that appear as an edge view here. I'll start once again by lightly drawing in the box, the rectangular prism that's going to appear in the isometric. And the next thing I will do, I will put my top surface 1, 2, 3, 4, 1, 2, 3, 4. Now, within that top surface, my elliptical shape will appear 1, 2, and then 3 over. 1, 2, 1, 2, 3. And the parallelogram is oriented to the top view. So there's my elliptical shape. And then they run along the edge to this line. Now, for the actual inclined surfaces, they start here and over here, and they wind up at the bottom one grid high. So here and here. And if I very carefully draw those with light construction lines, those are the two inclined surfaces. Now I'll come back and I'll put my visible lines over my construction lines, and as we say, we typically leave all of our construction lines, since we are just sketching, my two inclined surfaces, and I realize that the lines that are parallel in the orthographic views are again parallel in the isometric. And that completes the isometric view, except for one line here. I need that edge that goes back from this inclined surface back into the object. Now for a little more difficult type problem, let's move to number 3. Here we have a rectangular prism to the rear and a cylindrical projection to the front, and the whole left side of this is rounded with the cylinder. To start with, I'm going to take the rectangular prism from the rearmost surface forward. It's 2 wide, and it's 4 high. And I'm just going to lightly put that in to give me a sense of space. There it is. Now the next thing I will do, I will take my circle representing my cylinder, I'll put it on the front face and create my elliptical shape. 1, 2, 1, 2. That's the center mark. The radius is 2. So very lightly, I'll put my parallelogram in for the front face. Then I will draw my flat arc, my other flat arc. I'll draw my rounded end, my rounded end. Where the cylinder hits the rectangular prism back here, there will be a line of intersection, an edge if you will, and you can see part of it in the top view here. So I need to move that curve back 1, 2 grids. So the center point is moved to here, and once again I'll construct the rectangular prism, and my flat curve goes to here, and then my rounded curve is to there. And the third part of this curving is on the very back surface where the rectangular prism gets to the point of tangency and starts curving around. So I have to move my parallelogram back 1, 2 for the third surface. Now 1, 2, 1, 2, but I only need part of my parallelogram, and I only need part of the elliptical shape. I need the rounded end like that. The next thing I want to do, I want to put my edge in and my lower edge that I'm going to see. To do that, I draw the long diagonal just like we did on the sketching plate. And that long diagonal shows me where the edge begins and where the edge ends. Where the edge begins and where the edge ends. With that, I'll add the rest of my lines and my curves. With my visible lines, again, I have an edge here. It begins there, ends there. And that's what the object looks like. Notice that as we round here, the flat gets to the point of tangency and runs out and simply turns into a curved surface. And since this is part of the cylinder, there's no edge here either. This is called a runout, where the flat surface simply runs out and starts curving. That's a runout. The fourth problem, after completing the third problem, is very simple in that the rectangular prism is flat on the bottom, and then we just have a curved end on this upper piece. So I'll draw the bottom end rather quickly. Then I'm going to move to the top surface here. 1, 2, 1, 2, 1, 2, 1, 2. And I'm going to take my rectangular prism, and again, I only need half. So here is my flat arc. Here's my rounded end. And then where this curved surface hits the flat surface on the bottom, I again will have a line of intersection. So I'm going to move my center point down to, and there's my parallelogram. Here is my flat arc. Here is my rounded arc. When I put in the long diagonals, once again, I'm directed as to where the edge occurs. And with that done, I'll simply go over, add my visible lines, whoops, we have a line here that we don't need. That's from assuming I was in the right place. Tell you what, we'll remove that and do it correctly. There we go. My flat plate is actually down here. Again, this curved surface runs out and becomes flat. This one is already flat. There is not a line of intersection here because that is a run out. Just for clarity, we will move this one over on this side to make sure that the lines appear correctly. And you can see that here is my run out, here's my back curved edge, and I know exactly where my edges occur because of those long diagonals from the furthest corner to the furthest corner.